Next example of homogeneous differential equation. Solve x divided by x dy minus y dx is equal to root x square plus y square dx. So shift this y minus y dx to RHS and take dx as common, and then shift this dx to LHS and this x to RHS. We have this dy by dx is equal to y plus root x square plus y square divided by x. And this is a homogeneous differential equation, as this y plus root x square plus y square as well as this x are homogeneous functions of same degree, and degree of each function is 1. This y plus root x square plus y square, its degree is 1, is homogeneous function with degree 1, and this divided by x, this is also homogeneous function of degree 1. And so it is a homogeneous. If how we can check this is a homogeneous function, that by using the definition of the homogeneous function, definition of homogeneous function. Whereas if the function expressed in the form x raised to n into some function of y by x, then we say it is a homogeneous function. So if we take y as common, then we have 1 plus this x as common, then we have y by x plus we have 1 plus y by x bracket square. Okay, that is the remaining is a homogeneous is a function of y by x. So this numerator is a homogeneous function of degree 1, this denominator is homogeneous function of degree 1, and therefore this dy by dx is equal to this is a homogeneous differential equation. Now we have to solve this homogeneous differential equation. So substitute y is equal to vx, y is equal to vx. Therefore, dy by dx is v plus x dv by dx. By using u into v, v x derivative of x is 1, x derivative of dv is what, dv by dx. Then substitute these values in equation number 1. So we have v value of dy by dx as v plus x dv by dx is equal to y as vx plus x square plus v square x square divided by x. And then take x common from this numerator. We have x in bracket v plus this 1 plus v square. After taking this x square common here, we have x at this place, x in bracket. After taking x square common from root, we have x, because root of x square is x. And so we have, this is, if you take root x square as common from root, then we have x in root 1 plus v square, and take that x common and cancel with this x. So we have v plus 1 root 1 plus v square, and then shift this v to RHS, so v minus v becomes 0. So we have x dv by dx is equal to root 1 plus v square. This is in the variable separable form. So separate the variables. After substitution y is equal to vx, this equation reduced to variable separable form. So we substitute, we separate now variables. So we have shift this root 1 plus v square to LHS. We have dv by root 1 plus v square is equal to shift this dx and x. We have dx by x on RHS. So integrating both sides after separating the variables, integrating both sides. So we have integration dv by root 1 plus v square is equal to integration dx by x plus constant of integration. Suppose log c is the constant of integration. And then this is by using the rule integration 1 by root a square minus x square is 1 by a log x plus root a square plus x square. So this is the rule, one integration 1 by root a square plus x square rule. So it is 1 by a log x plus root x square a square plus x square. So by using that rule, a is now 1, so 1 by 1 is 1 log v plus root 1 plus v square is equal to integration of 1 by x is log x plus log of c is constant of integration. Then resubstitute this v as y by x. So we have log y by x plus root 1 plus y square by x square is equal to log x plus log c. And then take x square as LCM. So we have x square plus y square, and after separating root, we have root x square plus y square divided by root x square is x. And then take x as LCM. Now we have y plus root x square plus y square. and then use the rule log A by B. So log A minus log B. This shift this log x to LHS, it become minus log x is equal to log C, and then log minus log x becomes divided by x square. That is 2 times minus 2 times log x. That is log x square. Log x square minus log x square. And then use the rule log A by minus log b is log a by b. Y plus root x square plus y square divided by x square. This minus log x become minus 2 times log x, and then m log x is log x raised to m. So by using this rule, 2 log x is log x square. 2 log x is log x square, and then log a minus log b rule. And then cancel the log of both sides. We have y plus root x square plus y square is equal to c, or y plus root x square plus y square is equal to cx square. This is the required solution of the given differential equation. So first identify that the given differential equation is homogeneous differential equation. Then we have to solve the differential equation. Next is what? X divided by x is equal to y minus x tan y by x. So the given differential equation can be written as dy by dx is equal to y minus x tan y by x divided by x. Okay. So after shifting this x to RHS, and then this numerator and denominator both are homogeneous functions of degree 1. So what is this numerator? Y minus x tan y by x. If we substitute if we take x as common, so we have y by x minus tan y by x, and this is the remaining is the function of y by x. Similarly, so this is the homogeneous function of degree 1 divided by x is also homogeneous function of degree 1, and therefore numerator and denominator both are homogeneous functions of same degree 1, and therefore the given differential equation is a homogeneous differential equation. And now we have to solve this homogeneous differential equation. So in order to solve the homogeneous differential equation, substitute y is equal to vx. So dy by dx is equal to v plus x dv by dx, and therefore this given equation become v plus x dv by dx is equal to, substitute y as vx. So here vx divided by x, and then take x as common and cancel with the denominator. We have v minus tan, and this x get cancelled, tan v minus tan v, and then shift this v to RHS, so v minus v becomes 0. So we have x dv by dx is equal to minus tan v. Then separate the variables. So we have dv by tan v plus dx by x, or is equal to minus dx by x is equal to minus dx by x, that is plus dx by x is equal to 0. And then tan v is what? Is tan v is what? Cos v by tan v means into cot v, and cot v is cos v divided by sin v. Dx by x is equal to, then integrating both sides after separating the variables, integrating, we have integration cos v by sin v dv plus integration dx by x is equal to log c, and then this log c is the constant of integration, and then integration of cos v by sin v means cot v is log sin v plus integration of 1 by x is log x is equal to log c, then log a plus log b is log a into b, x into sin v is equal to log c. So x sin v is equal to c by after cancelling log of both sides, and then x substitute v as y by x is equal to constant, and this is the general solution of the given differential equation. Next example is of the same type. X sin y by x dy is equal to x sin y by x minus x dy dx. So dy by dx is equal to, after shifting these dx to LHS and this factor to RHS, we have dy by dx is equal to y sin y by x minus x divided by x sin y by x. And this numerator and denominator both are the homogeneous functions of degree 1. Both are the homogeneous functions and are of degree 1, and therefore we say that this given differential equation is a homogeneous differential equation. It's substitute, and so to solve this homogeneous differential equation, substitute y is equal to vx, and so that dy by dx is equal to v plus x dv by dx, and therefore equation 1 becomes v plus x dv by dx is equal to, substitute y as vx sin v, y by x is v, minus x x sin v as y is vx means y by x is v, and therefore we have x plus sin x v plus x dv by dx is equal to, take this x as common and cancel the x, so v sin v minus 1 divided by sin v. And so x dv by dx is equal to v sin v minus 1 divided by sin v minus v. Then take sin v as common, so v sin v minus 1 minus v into sin v, so it's become minus 1 by sin v. After taking sin v as LCM, we have v sin v minus 1 minus v sin v. So v sin v and minus sin v get cancelled. So we have minus 1 by sin v. Then separate the variables. Shift this sin v to LHS. So sin v into dv is equal to minus 1 by x dx is equal to minus 1 by x dx. After shifting to LHS, we have plus 1 by x dx is equal to 0. Then integrating. So we have sin v dv is equal to integration of 1 by x dx is equal to c as the constant of integration, and sin v integration is minus cos v, because integration of sin x is minus cos x. So integration of sin v is minus cos v plus log x, 1 by x integration is log x, is equal to constant of integration, and therefore cos v is equal to, after shifting this log x, and by changing the sign we have cos v is equal to log x minus c, and cos v is equal to log x plus c1. Suppose minus c as c1, new constant, and then substitute y by x, v as y by x. So cos y by x is equal to log x plus c1, or just substitute here in this step v as y by x. So minus cos y by x plus log x is equal to constant is the final answer, is the required solution or general solution of the given differential equation. Next example of the same type, 2x minus y e raised to y by x dx plus y plus x e raised to y by x dy is equal to 0. So if we simplify this, we have dy by dx is equal to, that is shift this quantity to L, RHS dy by this, and take then shift this coefficient of dx to LHS and coefficient of dy to RHS. We have dy by dx minus is equal to minus 2x minus y e raised to y by x divided by y plus x e raised to y by x. And this is the, if you observe numerator, it is a homogeneous function of degree 1. Also the denominator is homogeneous function of degree 1, and therefore this equation, given equation is what? This equation number 1 is homogeneous differential equation, because numerator and denominator both are homogeneous functions of same degree. And then putting y is equal to vx. In order to solve the homogeneous differential equation, substitute y is equal to vx. So dy by dx is v plus x dv by dx, and therefore equation 1 becomes v plus x dv by dx is equal to minus 2x y as vx into e raised to y by x. Substitute directly y by x as v, or substitute y as vx. After cancelling x, we have e raised to v. Next step. And then divided by vx plus x e raised to vx, substitute y as vx, and then 2 minus v. After taking x common from numerator and denominator and cancelling, we have 2 minus v e raised to v divided by v plus e raised to v, and then separate the variables x dv by dx. Substitute this v to RHS, so we have minus v, then take v plus e raised to v as LCM. So we have minus sign as it is, 2 minus v e raised to v minus v into v plus e raised to v. And so on, simplify this bracket. After taking e raised to, multiplying e raised to v, we have 2 e raised to v plus v square. This minus v e raised to v and plus v e raised to v get cancelled. And then we have this. And then we have to separate the variables. So shift this quantity to LHS. So we have v e raised to v divided by v square plus 2 e raised to v dv is equal to minus this minus sign, and then shift this x and dx to RHS. We have minus dx by x, and so this is by shifting this quantity, we have plus dx by x is equal to 0, and integrating both sides. This is in the variable separable form. So integration of v plus e raised to v divided by v square plus 2 e raised to v dv is equal to integration dx by x is equal to constant of integration, suppose c1. Then 1/2 adjust to, that is the derivative of v square plus 2 e raised to v is what? 2v plus 2 e raised to v, because e raised to derivative of e raised to v is e raised to v. So I just multiply and divide by 2. So we have 2 plus 2 e raised to v, and then use the rule integration f dash x divided by fx. So integration of f dash x divided by fx is log fx, log of denominator. So log of, so we have the derivative of this at the numerator, and so by using that rule, integration f dash x divided by fx log v square plus 2 e raised to v, 1/2 log v square plus 2 e raised to v plus 1 by x integration log x is equal to constant of integration c1. Then after multiplying by 2, we have this, and write this 2c1 as log c, new constant, 2c1 as log c, and then use the log 2 log x is log x square, and then use the rule log a plus log b is log a into b. So log x square into v square plus 2 e raised to v is equal to log c, cancel log on both sides. We have x square is equal to v square plus 2 e raised to v is equal to c, and then substitute v as y by x. So we have x square in bracket y square by x square plus 2 e raised to y by x is equal to constant. And then after multiplying the x square to bracket, we have y square plus 2 x square e raised to y by x is equal to constant, and this is the required solution. So these are some problems on homogeneous differential equation for homework. The first problem is x square plus y square divided by dx is equal to x into y. So just shift this x square plus y square to RHS. We have dy by dx is equal to x into y divided by x square plus y square, and that is the numerator x into y is the homogeneous function of degree 2, divided by x square plus y square is again homogeneous function of degree 2, and therefore the given differential equation is a homogeneous differential equation. Also, all the remaining problems are the homogeneous differential equation, problems on homogeneous differential equation. So first convert the differential equation to the form dy by dx is equal to m by n. So first convert the problem to dy by dx is equal to m by n, and then substitute y is equal to vx. So these are the problems on the homogeneous differential equation. There are the answers, the solutions of the problems of these problems 1 to 8 solutions are given. These are the solutions of the problems. So solve all these 8 problems. Next problem is again on the homogeneous differential equation. Y dash is equal to y plus x e raised to minus y by x. Y dash means dy by dx. And so if you observe numerator y plus x e raised to minus y by x, it is a homogeneous function of degree 1. So divided by x also homogeneous function of degree 1. And therefore this is the homogeneous differential equation. And so we have to solve this differential equation by using substitution y is equal to vx. So substitute y is equal to vx, and so we have y dash is equal to y by x as v is equal to right here the notation is in the place of v here the notation is u. So substitute y as ux. So while writing these problems in your notebook, apply the substitution y is equal to vx. Don't write ux. And here is the instead of v the notation is u. So dy by dx is what? Dy by dx is v plus x dv by dx. Similarly to this, apply these notations that substitute y as vx, then dy by dx is v plus x dv by dx, and then the given differential equation becomes. So these are the problems from this another book. So the notation is instead of v the notation is u. So while writing in your notebook, write substitution y is equal to vx, and then dy by dx is v plus x dv by dx. So this write this y dash as dv by dx, dy by dx, and then substitute its value as v plus x dv by dx, and then solve the equation. That is, shift this v to RHS, and then we have this equation that dv by dx is equal to e raised to v dv by dx is equal to 1 by x, and then separate the variables. So integrating e raised to v dv is equal to integration 1 by x dx, and so we have the answer e raised to v is equal to log x, because e raised to v integration is e raised to v, and 1 by x integration is log x. And then v is just substitute then v as y by x. So e raised to y by x is equal to log x plus c is the final answer. So no need of this simplification. Or if you simplify, then what we have after shifting this e to RHS, we have log of RHS, because e raised to a is b, then a is log of b, because the reciprocal of exponential function is logarithmic function. So after shifting e, we have u is equal to log x plus c, and then substitute u as y by x. So log of log x plus c. So y is equal to x into log of log x plus c. This is the general solution of the given differential equation. Now just after integration, substitute this u as y by x or v as y by x. So e raised to y by x is equal to log x plus c, and it is a final answer, general solution of the given differential equation. So we'll see the remaining problems of the same type homogeneous differential equation in the next lecture.